Okay, class. If you missed class while we were doing this, our objective is to use the vertex and zeros to solve real life problems involving projectile motion. So we started with talking about taking some notes, the axis of symmetry and vertex. So we considered this first problem, which is 5x squared minus 20x plus 15 equals 0. So the first thing we're going to do is put it in vertex form. So first we factor out a GCF to make some easier numbers. And then what did I do here? I took what was inside the parentheses, and what did I do? Why was I able to do that? That's just this plain old subtraction property of equality. I moved the 3x to the other side. Now, why am I doing that? I'm getting ready to complete the square. Okay, so then inside both sides, that squared should be on the outside of the parentheses. So it's negative b over 2a, the quantity squared, and both of those are being added on both sides. You can do that because it's a property, addition property of equality. So that should be negative b over 2a. That's what we did back when we did completing the square. And I realized that is not something that I ask you to master, which is why I'm showing it to you. And then we'll talk about why this works. So what that meant was x minus 2 squared would equal this negative 3. If I added that, I formed a perfect square on the left-hand side, which is x minus 2. If you want to double check that on paper right now, stop this video and do x minus 2 times x minus 2, and you will get x squared minus 4x plus 4, which is what this whole big thing that I added to both sides equals 4, right? Negative b over 2a. Negative b, a negative 4 is a positive 4 over 2a, which is 2, and then squared. The whole thing gets squared. Remember that squared sign should be on the outside of parentheses. I just couldn't get it to work right. So it's on the outside of the parentheses. So, and that would equal the same thing. So we created a perfect square in doing by completing the square. So what if we moved everything on the left-hand side? So as I do that, I would have a negative 1 or positive 1 on the right-hand side, so subtract 1 from both sides. Move it to the left-hand side, and what does that look like? I sure hope that to you that looks like vertex form. So we talked in class about what is the vertex then? It would be 2, negative 1, because remember the vertex form is the quantity x minus h quantity squared plus k. Okay, so the h is 2 and the k is negative 1 since it's plus k. What did we add to both sides? We added negative b over 2a. So that negative b over 2a is exactly what is negative b over 2a. That turns out to be the 2 in this case, or the x term of the vertex. So the x coordinate of the vertex. That's what's going to be helpful, is that now you don't have to complete the square to find the vertex by putting it in vertex form. You can just find the x term. Once you have the x term, you can find the y term by plugging it back in. We're going to do that in just a minute. So now we're going to talk about projectile motion. A projectile is an object upon which the only force acting is gravity. This could be an object dropped, thrown or shot, upward, or at an angle. So think a rocket, a football that you're throwing, a softball, a cliff diver. It could be any of those things. Dropping something straight off a cliff, throwing something straight up or having it burst straight up like a rocket, or throwing something at an angle. Okay, gravity that you might have learned in science class is either equal to negative 9.8 meters per second squared, or gravity is equal to negative 32 feet per second squared. So these problems use a function that represents an object's height, which depends on 3 things. The time in seconds that we're talking about, h of t, the t is for time, the initial velocity, which in this case is denoted by v sub 0, or h sub 0, which is the initial height. Okay, so if you were to plug in g over 2, if you were to plug in that negative 32 into g and simplify, this thing in the blue is the formula that we're going to use. Pause the video, Write that down. Projectile motion is this h of t, where t is this, v is this, and h is this, right? Initial velocity, initial height, and time in seconds. So write all of that down. Okay? The next thing that we did is we looked at a problem. We said, write an equation for a basketball thrown upward from the top of a 48-foot tall building with an initial velocity of 32 feet per second. So what sort of things were we given? We were given the initial velocity, 32 feet per second. We were told that in the problem. We were also given the initial height is 48 feet. We were told that he was throwing it from a 48-foot tall building. We look at our equation, that's what we had. We wrote it down in the last slide. Negative 16t squared plus the initial velocity t plus the initial height. And all we do is plug in 32 for the initial velocity and 48 for the initial height, the things that were given in the problem. Now, what does that tell us? Now, what can we know from this? So that's a quadratic equation. What is the highest point of the ball will reach in the air? Well, we know if it's a quadratic equation, the highest point will be the vertex. So to find the axis of symmetry, that's that negative b over 2a that I was talking about. That's the x coordinate of the vertex is the axis of symmetry. So we just plugged in the b and the a. Notice this is a good substitution step. You plugged in b and a, so b was 32 and a was negative 16. I just simplify and I get x equal to 1. So notice on my graph, the line just showed up. That's x equals 1. That's somewhere where the vertex is going to be. Now I want to find how high it goes on that line. Well, that's going to be the vertex, right? All I do is I take my equation for x, or my number for x, my variable x is 1, so I have to substitute in a 1 wherever there was an x in the equation, right? So we could do this for years. You've been able to have a table, and when you're given x is 1, you plug it in to find what y is, right? When you had y equals, say, mx plus b, you would plug in whatever, you'd plug in and you'd substitute in the value for x and you would find a value for y. So now we're doing that and we solve this. So 1 squared is 1 times negative 16 is negative 16. 32 times 1 is 32, and I get y equals 64. What does that mean? It means that the vertex is 164. Again, what does that mean? It means that the basketball reaches a maximum height of 64 feet after 1 second after throwing the ball. So, and on the graph, we see that the points are negative. At 48 feet is where it starts, and it goes up to 64 feet at its maximum height. And then we know that it's going to be symmetric. So as it comes down, when it's even at 48 feet, it's going to be symmetric at 2 seconds. Okay, so then what don't we know? Okay, so that's as much as we know so far of the graph. What we don't know is how long it'll take the basketball to hit the ground. We know it's going to be somewhere here along the x-axis when the height is 0. So since the height of the ground is 0 feet, what I'm going to do is set my y equal to 0, and then I'm going to solve this quadratic. To solve the quadratic, I can take the greatest common factor. So I can either try to factor this, or I could use a quadratic formula, whatever you prefer. Factoring's always cool when it works. It doesn't always work. So this one, it worked. I knew that I could factor this because if I did a times c, that'd be negative 3. So what multiplies to negative 3 and adds to negative 2? Well, negative 3 and positive 1 do. So that actually means I can use the zero product property, and I can have my two solutions of x equals 3 and x equals negative 1. What does that mean? That means that's where my parabola goes all the way down and it crosses at negative 1 and 3. So technically, those are my zeros. When the height is 0, the time will be negative 1 and 3. Of course, you can't have a negative 1 time. You can't go back in time. So you only take the one that makes sense, and you say it will take 3 seconds for the ball to reach the ground. So now we've learned how to take something, our original equation, and we found the maximum, the vertex, and now we found the 0 where it's going to hit the ground. It's not the only thing we can do. What if you wanted to find out how long it will take the ball to reach a height of 10 feet? So when it's at 10 feet, well, that means the y is 10, because the height is 10. Notice the y-axis is height in feet and the time is seconds. And the x-axis is time in seconds. So if this is my original equation, I'm going to set y equal to 10, substitute a 10 in for y, and I'm going to solve it. To solve this, I have to set it equal to 0 to solve quadratics. So I move my 10 to the other side, and I get this equation. So now I can't factor it, so I'm going to have to use the quadratic formula, where x equals negative, or a equals negative 16, b equals 32, and c equals 38. Now I'm going to use the quadratic formula. All I did was substitute in my a, b, and c, and then I just do the arithmetic, right? So the algebra's out of the way. We're doing the arithmetic. I'm solving, and I get my two solutions, one positive, one negative. As I solve this, I get x equals negative 8.37, so 10 feet. This line where it's going to cross, this blue line at the 10, this blue horizontal line, is going to be a negative 0.8 seconds. Well, clearly we can't go back in time, so we're going to use the positive side of 2.837. No, I'm talking really fast, so feel free to stop anytime and re-listen. The ball will reach a height of 10 feet after 2.837 seconds. So if you were trying to swish a basketball, that'd be 10 feet high, right? So you watch the guy up here on the 48-foot tall building, and he is trying to throw the ball into a basketball net. You would know that that would happen exactly 2.837 seconds after he threw it. Okay, and then we're putting those on the graph. That's what happens. Now you try. So after this, there's a whole bunch that you guys tried in groups, and that's what you missed on Monday, Tuesday.